Hello everyone, welcome back to my channel. I'm Bona. You're watching Math Mitra, your friendly math companion. In the previous class, we discussed about real numbers and types of numbers. Using that knowledge, we now study the fundamental theorem of arithmetic. Since your syllabus only requires the statement part of this theorem, you don't need to prove anything, you just need to write it correctly and clearly. Let me show you a clean way to start so you don't get confused later. First, understand the core idea. See, every composite number can be expressed as a product of prime numbers, and this factorization is unique apart from the order in which the prime factors occur. Just by seeing this theorem, you can't understand the logic behind this theorem. Before that, I'll explain what is prime factorization. Prime factorization is nothing but it is the process of expressing a composite number as a product of its primes. I'll explain this by taking an example. See, here I'm considering a composite number. Here I'm taking that as a 36 by using a long division method or by the ladder method. First we'll get the factors for 36. Here I am dividing 36 by using a lowest prime number, that is 2. Okay, so 2 ones are, so it becomes 16, 2 8s are 16. Again 2 9s are 18. So you can divide 9 by 2. So the next prime number is 3. 3 3s are 9, and then it is 3 1. See, here I am writing 36 as the product of prime numbers, that is 2 into 2 into 3 into 3. And you can write this as 2 to the power 2 into 3 to the power, how many 3s are there? 2 na? So 3 to the power 2. Now you just concentrate on the word unique. Why this unique matters? Why? Because you can write 36 as a product of only these prime factors, which is unique. You cannot write 36 as 2 into 2 into 9. You cannot write it like this. Why? Because 9 is not a prime number, isn't it? 9 is not a prime number. So therefore this factorization is unique. I think now you got a clear idea about the statement. So whenever the question is like find the prime factors of a number by factorization method, always the final answer must be in prime numbers only. So this is all about the statement and the prime factorization. Now we'll move to the next topic, that is HCF and LCM of numbers. Here I am going to explain the concept of HCF and LCM by taking an example. We have to find the LCM and HCF of 12 and 8 by prime factorization method. First, here I am considering 12. Okay, so the prime factors of 12 are, use that long division method, start with the lowest prime number, 2 6s are 12, again 2 2 3s are, next prime number 3 1s are. So how you will write 12, that is 2 into 2 into 3, that is 2 to the power 2 into 3. Now what about 18? Get the factors for 18. Start with 2 2 9s are, next 3 3 3s are, again 3 1s. I will write 18 is equals to. Now what is a HCF? See, the definition of a HCF is this. See, the product of the smallest power of each common prime factors. See the common prime factors? 2. And here also we have 2. What about 3? Yes. In both the numbers, we have 2 and 3 as a common factor. So what is the HCF? The product of the smallest power of each common prime numbers. Okay, so here the common prime numbers are 2 into 3 and its lowest power. See, for the 2, here the power is 2 and here it is 1. So the lowest power is what? 1. For the prime number 3, what is the lowest power? That is 3 to the power 1. So the highest common factor is 2 into 3 is 6. So 6 is the HCF of the numbers 12 and 18. So how we will write that one? HCF of 12, 18 is equals to 6. So LCM. LCM is the product of the greatest power of each prime factor involved in it. That is C. LCM is product of greatest power. So the each prime factors involved in the factorization method is what? So the prime numbers are 2 and 3. Okay, for this prime factor, so the highest power is 2 to the power. For this prime number, the highest power is 2. So 2 square is 4, 3 square is 9, 9 fours are 36. So the LCM of the numbers 12 and 18 is 36. Consider second example. Find the HCF and LCM of 96 and 404 by using prime factorization method. Again, get the factors of 96 by using prime factors. Start with the lowest prime. 2. 2 4s are 8. It becomes 16. 8s are. Again, start with 2. 2 2s are 2 4s are. Start with 2. 2 1s are 2 2s are. Again by 2. 2 6s are 2 3s are and 3 1s. How will write 96? That 96 as 2 to the power 1, 2, 3, 4, 5. 2 to the power 5 into 3. Again get the factors for 404. Start with 2. 2 2s are 0, 2 2s are. Again start with 2. 2 1s are 0, 1. Since 101 is a prime number, you cannot divide it by any other number. So now I will write 404, that as 2 to the power 1 2 into the 101. So what is the HCF? HCF of two numbers, that is 96, 404. That is the product of the smallest power of each common prime factor. Okay. So what is that common prime factor? 2. The smallest power. See, we have 2 to the power 5 and 2 to the power 2. We have to consider 2 to the power 2. So the HCF is what? 2 to the power 2 is. So the HCF of numbers 96 and 404 is 4. Now the LCM. LCM of 96 and 404. So what is the definition of LCM? That is the product of the greatest power of each prime factor involved. Okay, first we'll write all the product of prime numbers, that is 2 and next 3. So here we have already written that 2 and the remaining one is what? 101. So what is LCM? LCM is the greatest power. See, here we have 2 to the power 5 and 2 to the power 2. We have to consider 2 to the power 5. And we have only the 3. Here it is. And 101. So the product of all the prime factors gives you what? This one. This is all about the HCF and LCM of the numbers. So after the concept of HCF and LCM, there is a relationship between HCF and LCM, which is very important for the exam point of view. See, this is the relationship. For any two positive integers A and B, the product of HCF and LCM is equals to the product of those two numbers. So let me explain the relationship between HCF and LCM of the two numbers by taking this as an example. So the factors of 36 and 62 are like this. So now HCF. HCF of 36, 62. So what is HCF? That is the product of smallest power of each common factor. So here the common factors are what? Only its smallest power, here we have 2 to the power 2 and 2 to the power 1. So the 2 to the power 1. So 2 is the HCF. Now the LCM of 36 and 62. So the LCM is the product of the greatest power of each prime factor. So the each prime factors are what? 2 and next 3 and next 30. Its greatest power. For the 2, the greatest power is what? 2. For 3, it is 3 square and the remaining is 30. The product of all these prime numbers is what? 1116. Here I am going to verify that relationship. See here the value of A is 36 and the value of B is 62. And I got the HCF of those two numbers, that has 2, and LCM of those two numbers, that has 1116. Now let's verify. Consider the LHS part of the relation, that is HCF of 36, 62 into LCM of 36, 62. So what is the HCF 2 into the LCM is 1116, and the answer is 2232. Now I am considering the RHS part of that relation, that is A into B. So the value of A is 36 and the value of B is 62, and the answer is 2230. Okay, so see the LHS I got that as a 2232 and RHS that as a 2232. So therefore LHS is equals to RHS. The relation verified. So this is how you have to verify the relationship. You may get the question like this. If HCF of the two number is 2 and LCM of the two numbers is 1116 and one of a number is 36, find the another number. So to get another number you have to use this relationship. In next session we will discuss the exercise 1.1 of this chapter. If you found this session helpful, please subscribe to my channel so you don't miss our upcoming lessons. And also if you have any doubts regarding today's class, just leave a comment. See you then.